Here are four important strategies to simplify trigonometric expressions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll learn how do we simplify trigonometric expressions. The idea is to move forward with trigonometric identities. We have four expressions here which we will be simplifying one by one. So let's begin with the very first one and see how do we simplify this. We are given sin x over 1 plus cos x over sin x. Now to simplify this, we can take the common denominator, right? So if we take common denominator, what do we get? We get 1 plus cos x times sin x, correct? And in the numerator, we'll get sin x times sin x, which is sin square x, plus cos x times 1 plus cos x, correct? Now let's open this bracket, the distributive property. We get sin square x plus cos x times 1 is cos x plus cos square x, correct? Divided by 1 plus cos x times sin x. Now in the numerator, you see sin square x plus cos square x, right? That reminds you of Pythagorean identity, which is, we know that sin square x plus cos square x is equal to 1. So therefore, we can write this as 1 plus cos x. In the denominator, we have a factor 1 plus cos x. Do you see that? Times sin x, correct? So clearly now we can cancel this common factor, and what do we get? Well, we get 1 over sin x. So that is how you can simplify it. And 1 over sin x can be written as cosecant x. Makes sense. See, we have simplified this expression and written this as equal to cosecant x. Do you see that? So this is the power of understanding how do we simplify these expressions. And this is going to help us further in proving identities. I hope it makes sense, right? I'd like you to pause the video and simplify the second expression. Well, in case you want to learn from me, feel free to send an email on the address given. Most of my students are doing extremely well. So, the expression given to us is sin square x over 1 plus cos x. To simplify this expression, we will rationalize. Rationalization means multiply and divide by the conjugate, in this case of denominator, which will be 1 minus cos x. Clear? Now, in this particular case, when you do this multiplication, what do you get? Well, as you know, a plus b times a minus b is equal to a square minus b square. So, in the denominator, we are going to get 1 minus cos square x. Is that clear to you? And in the numerator, we have sin square x times 1 minus cos x. Now, what is 1 minus cos square x? Well, you know the Pythagorean identity, which is sin square x plus cos square x is equal to 1. And therefore, we can write sin square x as 1 minus cos square x. Makes sense? Correct? So using this property now, we are going to rewrite our expression as sin square x times 1 minus cos x over, instead of 1 minus sin square x, cos square x, we'll write sine square x. Is that clear to you? Perfect. Now see, we are able to cancel sine square x from numerator and denominator, and that gives us the simplified version, which is 1 minus cos x. Makes sense, right? Perfect. So that is how we are going to simplify this expression. Well, you could have started with the numerator, writing sine square x as 1 minus cos square x, right? And then factoring the numerator and getting the same result. You could have done that. So I'd like you to follow the second alternate method and redo the question. I hope it makes sense. So with that, we learn very important techniques to simplify these two expressions. Perfect. Now let's take up the third and fourth problems. So we have cot square x over 1 minus cosecant x. Well, you remember, what is 1 plus cot square x? It is equal to cosecant square x. Therefore, cot square x can be written as cosecant square x minus 1, right? So here we are going to apply the second strategy, which we talked about last time, right? So we have cot square x over 1 minus cosecant x. We can write cot square x as cosecant square x minus 1. Makes sense? And in denominator, we have 1 minus cosecant x. Now the numerator can be factored, right? Which will be cosecant x minus 1 times cosecant x plus 1, difference of squares, divided by 1 minus cosecant x. Now you see, in the numerator and denominator, we have a term, but this will go minus 1 time, right? And therefore, what we get is minus of cosecant x plus 1, perfect? Which is negative cosecant x negative 1. Makes sense. So here we have used the second strategy. You get the idea. So we could write it as difference of squares, factor, and then get the result. So that is another way of simplification. Perfect. Now let's do the fourth one, the last example, and see how do we really simplify these. We have 1 minus 2 sin x cos x over sin x plus cos x. Now see, we learned that sin square x plus cos square x is equal to 1, right? So we can write 1 as sin square x plus cos square x. You see that? And therefore, we will write this as sin square x plus cos square x minus 2 sin x cos x over sin x plus cos x. Now see, the numerator can be written as a perfect square. We can write this as sin x plus cos x whole square, right? And the denominator is sin x plus cos x. Now, cancelling one of these factors, we get the result in simplified form, which is sin x plus cos x. Do you see that? How beautifully we have utilized the Pythagorean trigonometric identity to simplify this particular expression. And now these 4 strategies which we learned are very important, and if you understand these, most of the trigonometric identities can be proved very easily. I hope it makes sense. Well, in case you want to learn from me, feel free to send an email on the address given. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.